All right, welcome back. I know there's a couple more sections here, but hopefully these will go relatively quickly. We'll be able to get through these all in this one video. So as I mentioned above, we've got this figure right here that it's not really professionally done. It's we've got these bizarre names for the x-axis, the y-axis. We don't have things labeled appropriately. Like if we were going to turn this into a journal, and a reviewer would rightfully so complain that this figure is not presentable. So that's where the labels come in. So there's a labels function, LABS or labs, and there are different arguments to this function. We can add a title, subtitle, caption, axis for the x-axis label, the y-axis label, and for basically every other aesthetic. So labeling is an extension of the aesthetics on the graph. So what I want you to do is, as an exercise, again, once this video is done, go back and rebuild this graph, but add appropriate labels that would make the graph basically ready for prime time, ready to go into a journal, ready to get published. And practice working with the labels. To be honest with you, a lot of students, they're gonna look at this graph right here and they're gonna say, I'm done. I showed what was happening on the x-axis, I showed what was happening on the y-axis, and I wrote this, I go back here and I write this long paragraph explaining what the x-axis is, the y-axis is, and why this cylinder is on the color axis and all of this other stuff. But we still need to have it labeled on the axis labels and the color labels and the size labels and all these other sorts of things, including a nice title and subtitles and captions if necessary. Here's why. I'm gonna take a minute and explain something to you. This was probably about 3 years ago. This is midway. This is early in the COVID pandemic. This is probably summer or fall of 2020. Maybe summer. Maybe it was the Delta wave in the summer. That I was working with some of the folks here, and I was working with some folks in the Department of Epidemiology, Department of Biostatistics, and we were building figures to help show the trajectories of the number of positive COVID-19 cases that we were finding out in, quote unquote, out in the wild, if you will. So people that were showing up for testing at a CVS or at the hospital or whatnot. And so we were showing the number of positive tests, we were showing the number of negative tests, we were showing the proportion positive over time, and so forth. And we found that we would put these figures online, or we would show these figures. One of the things that happened was we were on a Zoom call with some of the elected officials and some city officials, like appointed city and county officials, and someone asked for the graph, and so we sent them the graph, and then all of a sudden that figure ends up in as part of like a newsletter or something where this particular person was saying, oh, see, this is what's happening with the cases and this is why we're making the decisions. The issue is that we had kind of, I mean, we're back at that point, we were burning the midnight oil, and we were working 7 days a week. We were working, oh God, I don't even remember how many hours a day. It was exhausting. Just constantly going and going and going, analyzing the data, and reporting on the data, and cleaning the data, and just trying to understand, trying to make heads or tails of what's going on with the pandemic. So I had taken sort of the lazy route, and I was just like, okay, this is good enough. We're just going to be on this call, and my labels looked kind of like this. They were not very professional. And then, much to my dismay, I see one of my figures on like one of the Twitter accounts or social media from this area, and I'm like, oh my gosh, if I had known that this figure was going to be going out all over social media, I would have made sure that the labels looked good. Now, did I have the write-up in the report? Yes, absolutely. I had this paragraph in the report, but they didn't take the screenshot of the paragraph. They only took the screenshot of the figure. So make sure that your figures can stand alone, just in case they get all out onto social media, or God forbid somebody calls you up and says, I think you're lying in your figure, your data is garbage, all of the stuff. that you're protecting yourself and you're saying, okay, nope, this is where and you can have in the caption like where you got the data and all sorts of stuff. The more information you put in a figure, there is a point at which it's too much information, but I usually err on the side of adding more information to a figure rather than having less information in a figure, just because it's easier for people to see very quickly what's going on in your data. So anyway, that was this exercise. Go back and add nice professional figures. Get in nice professional labels to this figure. Get in the habit of labeling your graph, because you never know when it's going to end up on Instagram or Facebook or Twitter or whatever. So anyway, the other thing that we can look at, which is not as helpful here in this case, but we can look at facets, where we look at slices of the data at a time. And the reason it's called a facet is you can think about like the facets of the cut of a diamond, that as you rotate a diamond or rotate a gemstone, you can rotate it a certain way and look through the gemstone and see the cuts, and it will show different aspects of the gemstone. So that's sort of the idea here, is that we want to rotate the data or cut the data in certain ways so that we can see different cuts of it. And what's kind of interesting here is if we facet on, this is, I want to say fuel type. Once we facet on fuel type, the regular fuel, we see this nice clustering pattern that as the engine gets larger, the highway fuel economy goes down. And so that we notice that a bunch of the noise that we had seen was especially due to this premium gasoline. For whatever reason, cars that take premium gasoline, they don't have the same relationship between the engine size and the fuel economy as cars that took the regular gasoline. And even cars that take ethanol or diesel, or I honestly don't even know what C is. There's only one data point. These probably could have all been grouped in, and we could have just said, well, is it premium or is it regular, or premium or not premium? But you see this nice clustering in the clouds of points here, that we see because we are faceting. We're rotating the data, if you will, and just looking at it slice at a time. So now we can also add other facets, but again, the more you facet the data, you get to the point where you're looking at so many subgroups that you can't even see any signal anymore. So this is a cautionary tale to, say, be careful. Don't facet your data too much. You want to make sure that your data is still telling a compelling story. And this is not compelling. This is an accurate representation of the data, but it doesn't really tell us what's going on. So just be aware of that. Okay. And that's part of this exercise right here. Really discuss this. Can you figure out why we don't see the negative relationship between between the engine displacement and the city? This is city fuel economy here instead of highway fuel economy. See if you can pick out why that is. And it's actually kind of interesting. It's one of the ways that you can use charts to sort of hide the truth rather than make it obvious. So think about this, discuss this with your neighbors, and then tell me what you think. Finally, and this is where we get into more of the philosophy of how we write ggplot code. I have mentioned multiple times in these videos that the layering absolutely matters. So use layer organization rules to make sure that a later layer that you write, so you've got all of this code, you don't want the code down here at the bottom to overwrite something important that you put up here at the top. So you don't want it to overwrite something important in an earlier layer. And I will be completely honest with you, this is a huge and significant pain point for so many new ggplot users. If I had $1 for every single time I had a student come into my office or send me an email or come through the statistical consulting or biostat consulting group or the bioinformatics consulting group and say, okay, I built this ggplot, but for whatever reason, I can't see this part of my data, but it's right there. You look at the code, it's right there. And then we realize, well, they have this layer included right here, but that's overwritten by another layer down here, and they didn't realize it. So that happens when you're not organizing your layers. if you organize your layers, then all of a sudden you're moving them next to each other and you see, oh, wait a second, I've got a geom point right here and then another geom point right here. They would overwrite one. This one is going to overwrite this one. But if you have the geom point, the first geom point up here, and then 30 lines of code later, you have the second geom point. You've missed it. And you will miss the fact that this geom point is overwriting the one that was up above. So organize your code. Okay. So right here, the first chunk of a ggplot should always be the data. All right, so this is the data itself and any time that you need to modify the data. So there are times where in order for the ggplot colors to work, like for instance, if we go back up here, let me go back to this example. So right here, we've got the color, the year is on a gradient. But at the same time, there's really only two colors. There's either the 1998, which is this dark, dark, dark blue, almost black, versus the 2008, which is this super bright blue. Well, is that helpful? I mean, are we looking at years between 1998 and 2008? No, we're not. So it may make more sense to have this information displayed as what's known as a factor. And that's a particular type of data that we'll cover later when we talk about atomic vectors in lesson 6. But we could have represented the year as a factor and said, well, this is the 90s and versus this is the 2000s. And then that would open up the door for me to not use this blue scale because it's expecting this to be, look at it, it's saying, well, I'm expecting the year 2000, the year 2002, 2004, 2006, because I saw values at 1998, I see values at 2008, and I'm expecting values in between. Why don't I see values in between? Well, it's because this data set doesn't have them, but this particular, like whenever you use color on a feature that is continuous, it's often going to come back as a blue scale, when in reality, you may have wanted it to be a discrete feature. Like I see this happen a lot where people will have in their data set, they'll have the sex assigned at birth is male, and it will be a 1 if it's true or a 0 if it's false. And because that information is numeric, ggplot will interpret it like this. And so it will show all the zeros or women as like the darker blue, like super dark blue, and all the men as super light blue, but that's kind of confusing. And then you've got like over here, you've got some scale that's like, that includes 0.5 or something. You're like, well, what does that mean? And then you have to go into your data. It was like, okay, do I have people in my data set with Klinefelter syndrome or Turner syndrome where they're on sort of like the spectrum of sex assigned at birth? But that doesn't make sense because the doctor wouldn't assign the sex at birth based on these syndromes. And so you're just like getting all confused in your data because you're not recognizing that what R is interpreting as a numeric sort of continuous piece of information, ggplot really wants to display that as continuous information, but the information itself is discrete. It may be ordered, maybe not ordered. Like it might not be, or there's no ordering to males versus females. It's not like, oh, males are more important than females or females more important than males. These should be represented by colors that are not on a gradient or by shapes or something like that. So just be aware of that, and you can make the modifications to the data that you need to make in the data layer. I recommend that you do that there. Like you say, okay, here's my data equals whatever, and you modify the data right there. The next component would be the aesthetics, and this includes themes, this includes the actual aesthetics mappings, anything related to limits, scales, and labels. All of that goes here, okay? And then next, we would have the geometric objects or statistical objects. So any calls to geom underscore stuff or stat underscore stuff, this all goes here. And then finally, facets come last. The reason facets come last is because facets will multiply the figure that you already have. So if you have a good figure, you're going to get 3 or 4 good figures. If you have a really bad figure, you'll get 3 or 4 copies of a really bad figure just looking at different sections of the data. So you want to make sure that the facets come last. You want to make sure you have a good figure first, and then you can add on facets. And I'll say this, these rules may seem arbitrary, and they are a bit arbitrary, to be completely honest with you. However, these rules are the summary of, I don't even know how, a decade, I guess, of me beating my head against ggplot code, either for myself or for other people that come into my office. And it's just one of these things where, yes, it's a rule that kind of doesn't make sense on face value, but it does represent a lot of experience and fixing a lot of pain points. So for this class, I want you to adhere to these rules as if they were gospel. Once you're done with this class, you can go do whatever you want. You can make all sorts of confusing and convoluted ggplot code. I don't care. As long as it works, that's up to you. I really don't recommend it because later on, 6 months later or a year later, your future you is going to be kicking you in the pants. But if you don't have to adhere to this after this class is over, but I'm going to really, really recommend that you do. So anyway, and then because this is one of the longer lessons, there's always further reading. So I would say go and dig through, especially the ggplot2 cheat sheet. This is super. Oh, well, that's not good. Huh. Try that again. Well, okay, I'll have to fix that link. So anyway, ggplot cheat sheet, ggplot2 cheat sheet. And here's something. Notice they're using the double colon for packages as well. Okay, here's ggplot2 cheat sheet. Okay, yeah, this is what we want. Super helpful stuff. So that will help you, and I'll try to get this link fixed soon. Alrighty then. Well, next lesson, we're going to go into some ggplot examples. Alrighty then. See you next time.